Okay, hi everyone. Can you hear me okay? All set
Yep.
to go? All happy? Oh, Ammar's gone off camera. Okay, so you all got my email this morning just with the final details? Yeah, so are you all ready to share your screens? Obviously, I've got a copy of your presentations, but if you can be ready to share your screen, have everything else switched off, that would be ideal. I'll introduce you in the order that we have. So it'll be Anna, Ammar, Larissa, Amma, and how do you pronounce, is it Saya?
Yeah, you can address me, Sia.
Sia, perfect.
Yeah.
Just so I get it right. Sia. Okay, perfect. So it's in that order. Anna, Ammar, Larissa, Amma, and Sia. And what we'll do is I'll introduce you. So if you're ready to share your screen at that point, put your camera on, share your presentation, and then stop sharing, and then we'll take questions from the judges. So approximately 2 or 3 questions, and then you're good to relax, and we'll move on to the next person. Then we'll do a 10-minute presentation where the judges will deliberate, and then we will announce the final 3. We'll also give you feedback in terms of your scores and your comments afterwards. But essentially, keep your cameras on. So when we admit the waiting room, we'll do a few comments, and I'll ask you to do a wave to the audience, and then switch your cameras off, and then Anna will be next up. That all good? Yeah, good stuff. Good. Lots of thumbs up. Good. Okay, we'll relax for a few minutes, and because we've got about 12 minutes or so, we'll just wait till a few more people have entered the waiting room, and then we'll get going. But I'll let you know just before we start. Okay. Any questions? You'll see the judges on the left-hand side all eagerly waiting your presentations. Give everybody a wave. Can you see everything okay from your side? Yep. Give me a thumbs up if you can see the judges.
Yeah.
Perfect. All right, I shall leave you to have your last minute thoughts, and then we'll get going in about 10 minutes time. All right, thanks guys. I actually felt absolutely fine when I first woke up at 8:30, and then at 2 it's very same with my first one. My husband was like, well, we're looking at close clock to go to Miller and Carter, and I was like, oh my god, nightmare. I've still got my hand sparkling though, so that felt like taking no, I felt way worse. I felt better. I felt fine when we first left the suite, but then because the taxi takes so long to get there, and then I arrived home and took my cowboy hat off, locked the door and everything, and then got to bed. And my husband was like, "Yeah, right." And I was like, "Yeah, fine, fine." And the next morning, I was like, "It's what the dehydration died." Leon and I ended up. Oh, you're joking? That's hardcore. I could not be there for you. No, neither can I. Yeah, I know. Back in the Mexican days, yeah, I was there a lot. My friend from school dragged me there. It must be about 5, 6 years ago, and I remembered everything I hated about it. And it's like, I'm too old for this now. Sticking to the carpet. I even managed to get a face wipe to take my glitter off my face and everything. So I was quite pleased with that. Adam's wife was there, and pretty much everybody else was there. Yeah,
I'm guessing that when they start their videos, that's when you can place the spotlight, is it? It's not position up when the video starts or
No, you have to do it one by one, I think.
yeah, but I'm guessing that it's when they start their video because the moment they can't do it. So
Yeah, because we have to make them all co-hosts as well. Sorry, I forgot about that. They're sharing their screen. So you've got the presentation, it's just a backup. So if we make them all co-hosts.
you have to do it one at a time.
No, I think you can do them all. Make sure you can do them all. You certainly can do more than one. It's not working a bit yet. No, I think we're good. Everybody's got water and yeah. We've got water. So is that the bottles of water, Adam, all right in terms of the screen? Are you happy with it?
Yeah.
Yes. So I moved it and it was like so I take it one and just come back at 7 or whatever and then I'll let you know. Somebody go up on the building? Paul will do that. Yeah. So what I'll do maybe then is kind of 5 minutes more strong zeros. Yeah, no, I think I looked at when you hang around. I mean, obviously, if Paul was here and Kieran was here, then fine. You know what, I'll leave us. Work up. Is that working okay?
Yeah.
Yes.
There's only one guy.
Very strange. Well, we said I know I 5 o'clock last night, so you started at 5:30 for joining us. Oh, but 3 now. Mercy is obviously one of the parents or spouses of Amma. I don't think you'll need it, to be honest. I just gave you that slide and a copy of the presentations, but I've told them to death that they'll choose their students. If need be, there's a folder that says EI students and it says paper 1, paper 2, paper 3, paper 4, paper 5.
I need to do it quickly, just ban it. And I'll just put a 1 minute warning slide up to be just you want me to just flash that up.
I normally just write and it when you start, so I can just go.
Good evening, everyone. I'm Paul Rushton, Technical Services Director at Global E&C. I'd like to thank you all for joining us this evening for the annual MSc competition. We're hosted by the Energy Institute, and we're joined here by the judges at Global E&C's Challenge Centre here in Aberdeen. I'd like to welcome you all, welcome the judges, and I'll hand over to Rebecca Allenson from the Net Zero Technology Centre to kick things off.
Thank you, Paul. I'll turn it back so everybody can see me. I think they're coming in from the other end. So good evening, everyone, and thank you for joining us. I had to look at my notes here. 20 years this has been running. 20 years. Have to say, I am not old enough to be at every single one of them. That's actually a lie. I am old enough, but I have not been at them all. So yes, it does show that there's a strong competition and also a strong group of talented students in the northeast of Scotland that do submit every year. So I'm looking forward to the presentations this evening. Bit of a strange one for us, hybrid, as we're currently coming out of COVID. Last year we did this all online, and I didn't actually get the memo till about Tuesday to realise that I was actually meant to be in here in person. So I actually had to put clothes on tonight and not sit in my jammies in my front room. So I do want to welcome everybody, and hopefully we have a good presentation session this afternoon. I'm going to hand over to Katrina because she keeps us all right, and will take us through the events and the timings for this evening. So over to Katrina.
Thank you very much, Rebecca. Welcome everybody from my side. So you should have the programme for this evening. So I just wanted to say welcome and thank you to the judges. You've heard from Paul and Rebecca already. We've got Andrew, who is representing EIYPM. We've got Dan, one of our regular branch committee members, who a lot of you will know. And we've also got Kieran, who's a rising star for Global E&C, as I'm led to believe. So no pressure. So I would like to ask the students that are presenting tonight to put their cameras on, if possible, and just give us a wee wave. That's possible. I can't see what's happening from behind the scenes. So no health and safety warning this evening because we're all online, or most of us are online. Just some guidelines for the evening. If I could ask those of you who have joined us to view the presentations, keep your camera and mics switched off during the presentations. If you wish to pose a question, then please raise your hand on Zoom and we'll keep an eye out for you. We'll try and we haven't got too much time because the students are presenting for 10 minutes and then 5 minutes questions. So we'll try to do a couple of questions from the judges, and then if we have some time left, we'll take a question from the audience. Following all 5 presentations, we will then go to deliberations from the judges, and having seen the presentation abstracts, it might take us a wee bit of time. So we have a short presentation from Project Director at Global E&C, Derek Thompson, on the speed of change, which we're looking forward to. So let's get underway, and let's welcome Anna up first from RGU. Welcome, Anna.
Thank you, Katrina. Let's make sure that this works. Hopefully you can see my screen. Is that all okay? Can you all hear and see me? Yeah. Okay. Am I good to go, Katrina? Yeah.
Yeah, please do.
Thank you. Okay, well, thank you all for the opportunity to present this evening. My name's Anna. I'm doing my MSc in Oil and Gas Engineering at RGU. And tonight I'll be speaking about my project, the determination of the parameters of flow control devices to operate effectively in a CO2 storage well in the following sequence. So first of all, I'll give you a little bit of the background, why I chose this, why it's important, and what my aims and objectives are. I'll then have a look at the current mitigations utilised in technology for my project. I'll then look at 3 real-life case studies, what the results were, and the conclusions drawn from that. So climate change is one of the largest existential threats to our planet, and to significantly reduce global emissions, large volumes of carbon dioxide must be stored. Carbon capture and storage, or CCS, is the removal of the greenhouse gas carbon dioxide from the use of fossil fuels or biomass, and its permanent storage onshore or offshore. Now, the carbon dioxide is generally stored in depleted oil and gas fields, as you can see in figure 1, or in deep saline aquifers, which both consist of porous and permeable rock overlain by an impermeable cap rock seal, which prevents the upward migration of carbon dioxide. A depleted oil and gas reservoir is one assumed to have a lower pore pressure than it did originally, which therefore allows refilling of the reservoir up to its original level. So these are good to use because they're well characterized from previous oil and gas operations and hold substantial storage capacity. But CCS poses unique challenges due to CO2 phase behavior. So the phase diagram in figure 2 transcribes the phase boundaries for carbon dioxide with the variables of pressure and temperature. So along the saturation line here, liquid CO2 and vapor coexist, and the carbon dioxide is complex as it expands across the operating envelope of a CCS system. So carbon dioxide is typically captured in plants at the vapor phase, but is transported and stored in the liquid phase, i.e. above this critical point here for maximum storage. But during steady state injection into a depleted reservoir, as the compressed CO2 flows from the injection well into the targeted formation, depressurization will occur. And if the reservoir pressure is low enough, this will lead to the carbon dioxide transcending this saturation line into vapor. Now, this change to gas phase could result in greater cooling than if it stayed in the liquid phase. And this is due to the phase change into gas, Joule-Thomson effect, and latent heat of vaporization. So if this carbon dioxide flashes, this can cause localized cooling, which can result in damage to the completion equipment, hydrate formation, and flow blockage. So we need a method to keep the CO2 in liquid phase. We could heat it, but that's above this critical temperature, but that's very expensive, and we're burning more hydrocarbons to do that. So the aim of my project was to determine the required functionality of flow control devices to keep the production of liquid CO2 in steady state flowing environments over the broadest possible physical parameter range. My objectives involved establishing what current mitigations were versus optimum solution, modeling 3 proposed North Sea CCS projects, and then analysing and determining the choke settings. So pressure in the well can be managed by the use of small diameter tubing, creating back pressure by friction pressure loss. Low pressure at the beginning of the life of the well means more back pressure on the tubing is required to keep the CO2 in liquid form. But as the cumulative volume of CO2 injected increases over the life of the well, the reservoir pressure will rise. So this means that later on in life, we're going to need larger tubing, either through the use of another well or recompletion. So we can see that available completion options for this friction-dominated approach are the single tubing, which gives us a limited range of injection, similar to a dual completion, or an insert string and concentric strings, which are both free-hanging and can cause severe vibration and loss of tubing integrity. So to look at a couple of these mitigations in a little bit more detail, let's look at case study A and B. So case study A has a bottom hole pressure here and CO2 injection rate. So we can see the maximum that we can inject with this, this is a 3.5 inch and 2 7/8 dual completion, is 0.8 million tons per year. Whereas, and if we look at case study B, we have 3 base case designs, but each design has limitation in regards to achievable injection rates. So we could use a small tubing beginning of well life to choke the flow and keep the CO2 in liquid phase. But then we'd have to move to dual completion and a larger tubing to handle the expected injection volumes over time. So case study A restricts the quantity of CO2, and case study B requires 3 different well types to achieve the desired quantity and react to changing pressures. Now, the alternative solution that I'm proposing is a downhole choke. So the solution of a downhole choke varies from these friction-dominated scenarios by creating a pressure drop to manage the carbon dioxide in liquid phase. We can use a normal tubing size, so therefore we've got a greater envelope of injection rates. So we would use an adjustable downhole choke, such as an inflow control valve or an ICV, which is an active device which can choke the flow. So as the reservoir pressure rises, unless choking is required later on, we can just open up these ports here, or you could remove the devices completely. We'd also have these inflow control devices or ICDs in the perforations. And this is when the flow area reduces from a large area to a small diameter path through this nozzle, which creates a flow resistance. So the use of these downhole variable flow restriction devices can respond to changing well conditions, meaning we don't need to have multiple wells or recomplete in later life. So my methodology consisted of carrying out a critical literature review to confirm the current mitigations I've just spoken about and what the ideal solution would be. Now, there's limited software on the market able to model carbon dioxide with inflow control. And it's important to use a simulator that can handle the thermodynamics of material phase change and heat transfer. Tandeka have developed a bespoke CCS injection model, which indicates the phase behavior of carbon dioxide in the completion. So the model simulates the choking effect of the downhole flow control devices, as well as manipulating the surface or wellhead choke to keep the CO2 in liquid form and avoid taking too much of a pressure drop in any single zone. So I first of all would model the high reservoir pressure, high injection rate, and this would establish the number of ICDs in the perforation zones, making sure we could inject through these, and this would be fixed. I then would model the low reservoir pressure, low injection rate to establish the maximum number of inline devices such as ICVs in the completion. So from these two bookends, I could then model the in-between results and analyze them to see if a solution was reached, and if so, what they would be. So let's look at some of the results. Here we have the measured depth and pressure in the reservoir. So we have case study A and B. The red steps indicate the pressure drop across each ICV, and the number indicates the equivalent orifice size that each ICV is open to in millimeters. It's desired that these red pressure steps occur to the right of this yellow critical pressure line, meaning that the injection conduit pressure is above the saturation line. So case study A is connected to an aquifer, so we can see that it's got higher pressure than case study B and only requires 2 ICVs, whereas case study B would require 5. And we would expect this because as the pressure is nearer to the saturation line, a lower pressure field is going to need more ICVs to choke that CO2 and keep it in liquid form. But we can see later on in life that neither fields require any ICVs. So overall, we can see that the higher the reservoir pressure and higher injection rate, fewer ICVs are required. And we can also see that 12.5 millimeters is the minimum orifice size that we would need. Case study C shows us that 25 millimeters would be the maximum equivalent orifice size that we would need. So if we go back to case study A with the dual completion, we said we could inject 0.8 million tons per year. If we, using my model scenario, we can actually inject 1.029 million tons per year. So therefore, with the model choking system, we can inject 0.0229 million tons per year more, therefore extending the life of the field operations. For case study B, instead of having 3 wells, we could avoid the use of the 2 new wells and just use ICDs and ICVs to cover the full range of operation conditions from initial startup to end of life injection. That's a considerable cost saving. So to summarize, we want to mitigate the Joule-Thomson cooling effect, stop thermodynamic flashing, and keep CO2 in liquid form. At present, there seems to be an absence of a cost-effective technical solution to prevent carbon dioxide flashing to the gas phase, whilst ensuring we have optimum injection potential throughout well life. But my project has shown that for 3 real-life case studies, liquid CO2 can be injected by manipulating the surface or wellhead choke in tandem with a fixed or adjustable downhole chokes. And the modelling shows that we would that the equivalent orifice size that chokes would need to be would be 12.5 millimeters to 25 millimeters. So an exciting project, and with that, I would just like to thank you for your attention, and I'm happy to take any questions.
Thanks very much, Anna. Any questions from our judges?
Yeah, I maybe jump in with one question. Hi, it's Dan here. Anna, great presentation. Thank you for that. I really liked the use of data there. That was very well thought out and well presented. I suppose one of the questions I always think about from a mechanical engineering perspective, you talked about the reliance on chokes. As part of your review or your, looking as part of the study, did you think about or look at any data around the potential choke reliability issues And uptime, you know, that's always a big concern about, you know, when we're handling anything in a liquid form. So I'm not quite sure of the nuances with handling liquid CO2, but just wondered if that was a consideration as you looked at your, you looked into your review.
Okay, thanks very much for the question. It's certainly an interesting one. I guess it would be kind of the next step of this project, but I guess I looked at some papers. So, for example, for the Shell GoldenEye, you know, in 2014, which is now Starega Pale Blue Dot Acorn, choke was actually considered to be their second top option. They were going to go with multiple wells, but one of their concerns was around chokes plugging, and with the using ICVs was having control lines. But actually with ICVs, you don't need to have control lines. They can be, so Tendeka's one, for example, is works by fluid harmonics. So it's like mud pulse telemetry and drilling. So you don't need to have control lines. And you know, ICDs and AICDs have considerable track record worldwide. You know, there's at least 150 wells. I know with one company alone have that Tendeka have supplied, for example. So I guess, so I don't think those are, I guess in production, they're very common. For CO2 injection, it would be the next step to qualify them, because I guess typically in the oil and gas industry, we're looking at high temperature. Here, we're looking at kind of low temperature. So the next step would probably be just double checking that everything would be okay, and through flow loop testing and that sort of thing.
Okay, that's great. Thank you for that, Anna. Thank you. Any other questions?
My one for you, Anna, is Rebecca here. Obviously, you've clearly demonstrated some of the benefits. So what's next for this? This looks quite an interesting concept. So are you planning to take it further, or what is beyond?
I'm kind of begging our company to take it further. What's the next step with this? Yeah, so it's got interest with the within the industry. So with the three operators that I've used, I guess government funding dependent. So I guess the next step, again, a little bit would be looking at the actual devices themselves, and what they would need, what the scope would need to be, and then also, I guess this has only been for steady state flow. So I guess transient analysis is out with the scope of this project. So having a look at start up and shut down. And I guess the first initial step would probably be, I've established that the equivalent orifice size of the choke would be 12.5 to 25 millimeters. But what does that look like? So it may not be that kind of oval shape I showed in the presentation, may not be the optimum. So kind of establish the choke coefficient, and also maybe do a little bit more modeling with CO2. I just did pure CO2, but the simulator can handle with impurities. So that would probably be the next couple of steps.
Perfect. Yeah, it does sound really interesting. I'm quite intrigued about the next steps.
Yeah, definitely.
Any further questions from the judges? Or?
Yeah, just one quick one. So, evening, Anna. Fantastic presentation and extremely well considered. I guess question as a non-engineer really, but as the material type for downhole product, is there anything new or novel that we could do to almost alleviate this whole issue, or the temperatures that you would see when the gas changes state is impossible to overcome?
That's
look to control the state, or is there a material that could actually accommodate these temperatures?
It's an interesting question. I don't know if there is. I mean, I think I guess another challenge, I guess, with CO2 injection is potential corrosion. So you're making sure that the CO2 doesn't have any water in it, and there's no material that can help if things start to corrode. But I guess trying to have that pressure, I guess the whole thing is it's difficult to inject with these low pressure reservoirs. So I'm not really sure if there's kind of more of a metallurgy around that. I guess for looking in these wells, we'd probably be looking at like tungsten carbide and quite strong materials. But yeah, if you come up with anything, then you might. Yeah,
I'll retire next week.
That's great. Thanks, Anna, for a great presentation. You can now relax and listen to everything. So next up we have Ammar. If you want to come on screen and share your screen once Anna's stopped sharing. Thanks.
Sorry.
Thank you.
Everything okay, Ammar?
Okay, I think just my camera. Okay. Just
Okay.
1 minute, sorry for that. Just bear with me, sorry. Okay. Can you see my screen now?
Yeah, it's just coming up. If we can just make it full screen and then we're good to go, I think.
Okay. Now, can you see my PowerPoint?
Perfect. Yeah.
Okay. Good evening, everyone, and thanks for giving us this chance to presenting today. This is Ammar Farouk Mohammed from University of Aberdeen with a dissertation titled Energy Market Risk Management in Iraqi Oil Marketing Company SOMO via Official Selling Price Dynamic Hedging Optimization Technique, DHO, OT. This is an empirical case study by which I got my MSc degree with distinction. And first of all, I'd like to make or do kind of a promotion for this paper, if you like. This scientific paper is at the core of the topics usually awarded Nobel Prize in economics. It has been described as a high quality piece of paper by Professor Alexander G. Kim. And needless to introduce who Professor Kim is, because he is an iconic name. And of course, when a respectful figure like him describes a paper by this way, so this means it's really worth it. Furthermore, this paper has been graded as A2, which means marked as 21 out of 22, which is conventionally the ultimate possible distinction grade that might be awarded by universities for a dissertation. By the way, if you read my abstract in the agenda of today's presentation, by mistake, I have mentioned it is A4, so please correct it yourself. It is A2, the right grade. Furthermore, this paper also has been awarded Professor Joseph Swerbinsky Prize for best postgrad dissertation in economics. And hopefully, this interesting event held by the Estimate Energy Institute will be a significant step to draw far and wide attention and get more academic accreditation in favor of this dissertation as a revolutionary scientific paper in pursuit to achieve my main goal of having a nomination to it to compete on which in economics Nobel Prize. So now moving on to see why this paper is worth it. First of all, regarding its methodology and even its ordinary aspects, it's kind of inclusive, where it is based on the portfolio insurance theory of put options against energy price collapse. And the dynamo of it is the Black-Scholes formula, which requires five parameters, and they are stock price, exercise price, and data risk-free rate, and volatility. However, maybe you find many other papers covered the same topics, but not as inclusive as this one, because it has covered all of the probability. For example, it considered the annual and semi-annual and quarterly insurance scenarios. Also, it has tried the valid and invalid volatility for oil price, of which from pandemic and pre-pandemic period. And all of that was employed by the deterministic strike price at $50 per barrel. That's what's ordinary till now. What is unprecedented and novel in this methodology is the idea or the novel technique, optimization technique, which as I called it, the dynamic hedging optimization technique for investing optimal strike price. Until the time of writing this paper, the convention prevalent in the option market is by offering a list of strike prices for put or call option of a share of a stock, which are valued accordingly. And the investor or option holder should choose one of these strike prices depending on its own purchase power. In fact, they will face two kind of mutual exclusive risks. One of them is when you will choose a high strike price, and then you will not need to exercise this option. You will afford a high cost, and it will be sunk cost. And vice versa. If you reduce your strike price and there is an official selling price collapse, you will sacrifice a lot of revenues. So both of situations are kind of dilemma. No one want any one of them to be on his conscience. So no one want to be blamed of that. But so what is the best strike price? This is the question of $1 million. This is the philosophical question, which is not answered until the time of writing this paper. So looking at this two novel equation formula at the right for the first time in this paper, these are the objective function used in the optimization. The first one for put option by maximization, and the second one for call option by minimization. And the K is the optimal strike price or the decision variable. What you are looking at now are two questions. I believe in the foreseeable future, they will have a high significance role in the markets. Till now, I didn't publicly publish this paper, but I'm sure after doing so in the near future, and the market players will be aware of them, they will reshape the work styles of all markets entirely, and they will change the way by how the option markets or let's say insurance crafts are managed nowadays. So no one knows what can come up. Maybe one day these two questions will be attributed or named after me. So moving on to this simplified influence diagram, the input data used in this dissertation actually come from two sources. The first one is the SOMA website, where the monthly quantities and revenues, and the second one is the U.S. Energy Information Administration, where from this website, I got the daily and monthly oil prices, and most importantly, the treasury bills for the risk-free rate. And as you can see from the deterministic and optimization calculation, many parameters and many tips have been covered in this in the calculation of this case study. But most important is the criteria employed to measure the visibility of this study. And the most important two are the in-kind percentage, which means the insurance cost, instead of paying them from the hard from the scarce hard currency, they will be paid by the in-kind from the abundant and available oil itself. And also the second parameter used is of how much from the previous year insurance cost will be recovered by the received revenue. So looking at this base case results, as we can see, it is a kind of panel data, and we have the four main criteria employed in this case study. The first one is the total insurance cost, and the second one is its value in kind person, and the secured revenue, and how much recovered similar insurance costs from the previous year. For the 2020, it's the best paradigm because we have insurance costs and secured revenue for this year. Because if the put options were in place, they will receive many a lot of revenues because of the pandemic. So we can see by the ordinary methodology followed nowadays by option market, it would cost more than $2 billion, and this which equals more than nearly 5% from the national income of the country. And this is unaffordable, of course. But by looking at the optimization, particularly unconcentrated optimization, we were able to reduce this to only nearly $250 million, which equal only 0.6 as in-kind percentage. And this would be able to recover more than $7.6 billion from the lost revenues during the pandemic, which equal as similar its cost of 30 years, which means if SOMO would have followed this methodology of the unconcentrated optimization ever since 1990 till now, and there was no any exercising for the options because the good state of nature, just sunk cost. By only the recovered revenues of 2020, it will cover all of these the previous costs. More interesting when we look at more dynamic hedging optimization of the unconcentrated optimization, where for the ensuring the first half only under a quarterly scenario, we will, as we can see, it costs only 0.3% from as in-kind percentage, and it will cover as such its cost for 65 years. So this is no longer just insurance cost; it's insurance investment. This cost has been turned by this optimization to be kind of lucrative investments. It would recover as $6 billion by this optimization. Also, there is a detailed sensitivity analysis has been conducted for two sensitivity robustness or tolerance, plus minus 1% as a marginal change and plus minus 20% as a considerable change. We can see from A and B above the diagram in the two shapes, the A is under the deterministic calculation. The other are by optimization. We can see how optimization eliminates the measurement risk of the parameters used in this calculation. And also we can see, graphically I have depicted the relation between the objective function and the strike price. And we can see we have smooth strict concave shape with one peak point, which means we were able to get the optimal, global optimal strike price, not just a local optimal point. And this is another advantage for this point. Okay, and also I want for your reference to mention that all the references quoted in this dissertation are seminal, and most of them were considered by Nobel Prize. And now, if you have any question, I will be glad to answer them. And furthermore, this is my contact detail. If anyone feels himself interested and to discuss this topic more later, I will be ready, and I don't mind to share this paper and its detailed module for free with anyone if he's interested with that. So please, if you have any questions, go ahead, I'm all ears.
Thanks very much, Ammar. Lots of information in a very short period of time. So over to the judges.
Well, maybe I'll start again, just a very quick question. So thanks for that, Ammar. I think, just an observation, I think clearly a subject matter that you're very passionate about, that certainly came across in the presentation. And I think, that's always a great characteristic to have and behaviour to have. So keep that going. Just one question for me. I was just thinking, maybe the $6 billion of rescued revenues kind of really piqued my attention. But I was really thinking about, where do you see the ideal application for this? Is this with the energy industry as a whole? Is it with the insurance companies? Is it with, not quite, I struggle just to get my own mindset where is the ideal application for this type of approach to land up on? So maybe if you could expand on that.
Okay, thank you. That's a great question. Actually, this is a case study on the level of the SOMO, which is the oil marketing company in Iraq, but it's applicable elsewhere. It is applicable for all markets, but the paradigm of it was the energy markets in this case. Actually, if you want me to comment more about this revenues, and when I calculated every year calculation, I was like, I were before it coming. So when I calculated the 2020, like I was in 2019, I don't know anything about 2020. Then I come this cycle price and injected in the situation of the pandemic, and this astonishing results come back to me. So the methodology of this case study, based on that, you will find the optimal strike price for future without knowing anything about it, without forecasting or make any projection about the future. And when the future will come, whether it will be a good state or bad state of nature or world, you will find yourself in both situations at the optimal position. And that based on the theory that the historical time series of stock prices implied within it what the position of that stock will be in different nature, different states of nature. And by implying the Black-Scholes formula under this novel optimization technique, we can withdraw, we can absorb from this information what will be the optimal strike price, which is unprecedented so far.
Okay, thanks for that, Ammar. Thank you.
Thanks, Ammar. That's really interesting, and as Dan said, there's certainly a lot of information. I'm really interested in the fact that you're modeling the results. Have you actually taken your model back retrospectively, so is that you've modeled a year without the data, and then you've been able to check back? So I see you've done 19. Have you done previously to that?
Yes, there is an input sheet, and you can change any of the inputs, and you will try another input data. For example, when I entered the revenues and the prices adopted from some website, you can change your own data instead of them, and the model will return another data. Furthermore, also there is auto optimizer sheet, which is separate, works separately. You can use your own option, boot option. You enter your data, your oil price, code date, expiration date, free rate, annualized volatility, and exercise probability, and the optimal output will return to you separately. So you can run your own data or your study on the same model. It is ready to that, to do so.
Okay, thank you.
Thank you very much. We'll keep moving with the agenda. Thanks to Ammar for a great presentation. And
I'm listening.
Next up, we have Larissa. Welcome.
Okay, hi, can you hear me?
Yeah, we can hear you fine.
Can you see my screen?
Yeah, we just have it in presentation mode, and then we're...
Okay, I'm so sorry.
No, good to go when you're ready.
Okay, I'm ready, thanks. Good evening, my name is Larissa Gonzalez, and I'm going to present a design and optimization of an efficient solar water pumping system for agricultural purposes at small scale. Okay, I represent the solar energy system, the Masters, for Robert Gordon University. Okay, here we have a little breakdown of the presentation. So we have the project background, the case of study, as well as the aim and objectives, the methodology, of course, the analysis of results, and finally the conclusions and further recommendations. So here, let's start with the case of study. Ramsing Farm is located in Kilmarnock Village, nearby Glasgow in Scotland. This site receives an annual solar irradiation of around 2 or 3 kilowatt-hour per meter square, which is equal to 1,216 sun-hours per year. And they are looking to power their house, a shed, and their future water pumping system. They have a 20,000-liter portable tank of is the storage tank of there. They have a gable roof, which is north-south orientation, where it's going to be installed the system. And they have an electricity contract with both energy companies. Here we have the project aim, which is to provide an optimized and mechanic model and a solar ideal layout, which is also cost effective according to the client's needing and taking into consideration the location and orientation of the site. Okay, the objectives of the project are to calculate the hydraulic charge and the power pump of the system, provide an ideal solar arrangement, to create a model for a storage package, and select the most cost-effective system, and to prove that cloudy locations are suitable to install solar systems. Okay, the steps taken for this project was the obtention of the total hydraulic charge and the power needed of the pump to Bernoulli equation, then the drawing of the system by AutoCAD, then the designing of 3 different solar layouts, which is the on-grid, the off-grid, and the hybrid system according to the power demand of the farm. Then the optimization and obtention of a method to observe a battery daily behavior and its curves. And finally, the obtention of an economic analysis, which is the profit, the payback time, the levelized cost of energy, and the selection of the best option according to this analysis, and of course, the performance of the system. Here we have as analysis of results, the total head of the system and the power demand calculations. Here we have the drawing AutoCAD, as I mentioned before. Here, the irrigation system is going to have 3 delivery points. This is the storage tank, and this is the solar installation. The flow rate of the system, the total head, and the power of the pump are the most important values here in the system. So the original flow rate is 2.26 cubic meters per hour, which is the flow rate of water, but this can be used at its half of its capacity or at the double of its capacity. It is important to know that the sizing of the solar system was done based on this power of the pump, which is the maximum power of the pump, okay? So here we have the total energy demand per season in the year, and this is the residential energy demand, and this is the energy demand of the pump that it was calculated. This plus this is the total yearly demand of the system, which is 23,601 kilowatt hour, which is equal to a power requirement of 24.6 kilowatt peak. Okay, here we can see are some simulations that were done in order to select the best power capacity of the module. This is the 370 watts and the 470 watts were the best in cost and performance. These are some specifications for the future installers as the area of installation and of course the distance from the edges and the tilt angle of the roof, and this will be the final layout of the solar system, okay? Basically, it's the same for every system. The only thing is going to change the number of modules. Here we have the analysis of results of the on-grid system and the off-grid and hybrid system. Here we have the energy sold, consumed, and stored to the grid from the hybrid system, which is the 6 battery one, and the 18 battery, which is the off-grid system. Here we can see that the energy sold in this color blue and this purple with 6 batteries and 18 batteries, the energy sold to the grid from September to March is going to be any sold of any selling of energy in this month. This means that the energy is not producing enough energy to sell energy to the grid and to fill the batteries. So here we have that the energy consumed when the months cannot sell energy to the grid, they are going to consume energy from the grid. And we can see here and here that the behavior of the 6 batteries and the 18 batteries are similar. This means that we don't need more batteries to store more energy. So we can say that the hybrid system is better, much better than the 18 battery system, because although the 18 battery is an off-grid system, it's still depending on the grid system and on the grid. So this is not recommendable to have a lot of batteries and still depending on the grid. So here we have the energy scheme of the on-grid system. This is the energy that the client consumes in situ. This blue line is the energy generated by the system, and this gray line is the difference. So it's the energy that is going to be sold to the grid. This is a scheme between 84% and 16% consumed to the grid, and 84, sorry, sold to the grid. So we can say here that this can be changed depending on the usage of energy on active hours of the system. Here we have the analysis, the profit analysis, which is the on-grid system, is the best profit with the 420 watts. The 6 battery is good as well, which is the hybrid system, and we can see that the 18 batteries is not recommendable at all. We can see here that the payback time is about 15 years to pay the on-grid system to recover the investment. The 6 batteries is around 20 years, and the 18 batteries is around 14 years, which is not recommendable because it lasts more than the lifespan of the system, which is 25 years. Here we have the levelized cost of energy with the different layouts, and the best levelized cost of energy is 5 pence of the on-grid system, and the 6 battery, which is 10 pence. The levelized cost of energy is a parameter to evaluate and compare conventional energies and renewable energies in order to see if they are ideal to be installed. As we can see here, the diesel generator is between 5 and 6 pence. It's around this amount that we have here. So our technology is being competitive with the diesel technology, and of course, we are going to have the return of our initial investment. The owner is going to generate their own electricity, and of course it is more friendly with the environmental, and we are going to reduce the footprint. As a conclusion, we have that we calculate in the mechanical model the total head of the system, the flow rate. We optimize the battery system from 18 to 6 batteries. We selected the best system, and the farmer selected their best system. It is the on-grid system of 420 watts of capacity, and we proved that the PV systems can be installed in cloudy locations like Scotland, where is not much sunny energy available during the whole year. As future recommendation, we have that this same layout can be tested in other parts of the world. It can be tested to see in order to see the performance changing, and we can change the orientation instead of south orientations to test the north orientations in order to see how is the change in performance. So that's all. Thanks for your attention.
Perfect. Thanks, Larissa. That was dead on 10 minutes. Very impressive. Over to the judges.
So I think I'll kick this one off. So 14 years sort of payback. Do you think our industry, or do you think the agricultural industry will actually buy into that?
No, of course, no. The recommendation of this system is that to go for the on-grid system. We were proving basically that more batteries does not mean storing the whole energy that you are producing. If you don't produce enough energy, it is not make sense to have bigger systems of batteries. So that's why we selected, or we suggest to the client that select the on-grid system, because it doesn't have batteries and the payback time is of course less. So that's why it is not recommendable to have this.
Thank you. Any other questions?
Yeah, one for myself. Really good presentation, well considered. I guess there's probably a couple of variables that I would consider when you talk about the battery. So how have you ever considered or accounted for varying the cell size themselves? And is there a way to optimize the number? I guess within the dissertation you've looked at 6 and 18, but is there a way to optimize on a sort of sliding scale to say, well, if you did have 2 large batteries, then you may see a benefit. However, when you go to 18 units, you don't see an upside. There's probably a few variables in there. Had you considered that through your research?
Well, the size was not taken in account, but of course they have a lot of, they take a lot of space, and but it wasn't taken in consideration. I don't know if I answered your question. I'm sorry.
Yeah, that's okay. Thank you.
No problem.
Hi, Larissa, Paul. Great, thanks. Lovely presentation. Great information. Did you consider changing the size of the water storage? So is that in the summer where there's more solar available, that you can pump more water at the time or store more water and then release it later? I assume that's kind of the model, that it's running the water through a hydro plant in order to generate the electricity, and you're just buying in and out of the grid as needed?
Okay. Oh, well, let's see. The storage tank was, I consider the 20,000 liters of storage tank. It was because it was the storage tank that the farmers own. So I had to take into consideration this, because this is the place where they store their water. So that's why it has to be taken into consideration. They were thinking about to place other storage tanks. However, they asked me to do this with the parameters that they have available at that time.
Okay, thank you. I'd misunderstood. I didn't realize it was an actual physical location already. I thought a lot of it was just building a model around what if. That's actually great to understand that it was a real farm with the equipment in place. So this is a real location.
Yes, this is the location. Sorry, yeah, this is the location.
Yes,
yeah.
Sorry, I didn't quite realize that's going to be asked to do that. Thank you for
no problem.
that for me.
Okay, thank you very much, Larissa. Thanks for a great presentation and some great answers there. So we will now move on to our fourth presenter, Amma.
Hi, I'm here.
Hi.
Hello.
Hi there, yeah.
Can you hear me just fine?
Yeah, perfect, ready to go. Thank you.
You can see my slides as well.
Yep, all good, thanks.
Oh, super. So, hello, I'm Amma from the University of Aberdeen. I recently completed a master's in global subsea engineering, and tonight I'll be the scope, demonstrating all the analysis techniques used to prove that an umbilical configuration in the North Sea environment was fit for purpose. My presentation will home in on this outline. I'll introduce the subject briefly, lay out the key objectives of the study, and focus on the model development and the analysis performed. I'll summarize the key outcomes and draw the necessary conclusions. As an introduction, according to BP's 2021 statistical review of world energy data, the offshore environment accounts for around 30% of the world's oil and gas, while that for wind, then that is already at 15% and steadily increasing. Umbilical cables are commonly used in offshore installations, from oil and gas platforms to offshore wind farms, connecting and transferring power between the offshore facilities to the seabed or onshore facilities. Present in harsh environments, the umbilical is designed to withstand loads as defined in Part 5 of the ISO 13628 standard. Part of this process is achieved using finite element analysis by modeling the umbilical cable in the dynamic environment. This presentation will examine a system of this nature. The behavior of the umbilical is assessed under normal and extreme conditions using analysis models such as OCAFlex software models. Based on dynamic analysis of such an OCAFlex cable model that I developed, this study sought to firstly verify the umbilical system design in extreme sea conditions, that is, looking at the worst case weather environment in a 100-year return period. Apart from extreme conditions, the operational wave effect of the umbilical is verified. Additionally, some sensitivity analysis is conducted to ensure that the design is robust. Now, global analysis was conducted on the entire umbilical configuration using FEA. Dynamic analysis was performed to ascertain the umbilical's response under wave loading conditions. This is the cross-section of the umbilical along with its properties shown on the slide. The entire configuration of the umbilical cable as modeled in Orcaflex looks like this. As I modeled it, the line with has its first end connected to the FPSO's turret and the second end anchored to the seabed with a tether system at an angle of 55 degrees. It is designed as a lazy wave configuration with the buoyancy section giving it some uplift in the middle right here. The development of this model will be explained in later slides. A key piece of information here is this: the vessel and the vessel motions were modeled based on the data depicted here. This is a representative selection of input data that have been used in the modeling process and the analysis process. The base case is the 8 different typical wave direction offsets considered based on the relative position of the hang-off and the touchdown position of the umbilical. Fundamentally, for all cases where the tension, bending moments, and curvature were critical outputs, the criteria for acceptance was based on the capacity curve shown right here. This is obtained from the UFlex 2D FEA local analysis performed for the umbilical cross-section, which presents the limits with bending stresses from 0 to a maximum based on material utilization limits of the cable, the cable's components, producing a maximum tension of 1,750 kilonewtons for 0 curvature and maximum curvature of 0.52 per meter for 0 tension. Load combinations must fall within the safe load region to be considered acceptable in the analysis. The preliminary global dynamic analysis adopted a simple catenary configuration at the start of the analysis. Due to inertia from the motion of the FPSO, this is propagated down through the umbilical line to the touchdown area. This configuration is deemed unsuitable as some of the load cases fail to meet the safe load criteria, falling outside the capacity curve limits. Iterations were then run, varying the length of the distributed buoyancy section and the volume of each buoyancy module. While results for A and C prove acceptable, there is room for improvement to make the configuration as safe from the limits as possible. The results for curvature were improved by increasing the volume of the individual buoyancy modules, which ultimately increased the uplift. As seen in B and D, by increasing the volume from 1.5 to 1.7 cubic meter, the tension and curvature as expected were improved. However, for these cases, there was insufficient on-seabed umbilical length. This affected the bottom tension required to keep the umbilical stable under operating conditions. In its final optimum form, the umbilical assumed a pliant wave configuration. This is a lazy wave configuration with a buoyancy section with a total number of 50 buoyancies with a total net buoyancy of 57 tons, where the umbilical is anchored to the seabed using a tether system. The umbilical is stable, and the results of this configuration satisfy the conditions of the acceptable criteria. In terms of extreme analysis, we examine the umbilical under worst case weather conditions over a 100-year return period. A range of parameters are verified as they change from the start of life, where the umbilical is clean, to the end of the design life, where marine growth sets in, along with buoyancy degradation. As can be seen in these plots, under both start of life and end of life conditions, the umbilical operates optimally, with the tension and curvature of the umbilical for all load cases analyzed falling well within the safe limits. Frequency screening was performed at a constant wave height of 10 meters between the 5-second and 22-second period. Here, the main interest was maximum tension, curvature, and bending moment values along the umbilical line. Irregular wave analysis was further conducted to verify the extreme loads we obtained from the extreme analysis, applying irregular wave profiles, which represent realistic sea conditions with a series of individual regular waves occurring within a 3-hour storm. This analysis also identifies any potential resonance periods previously missed. Loss of buoyancy analysis here assumed the loss of a single buoyancy element at the hog bend, together with a loss of 10% of the total uplift due to water ingress, on top of the end-of-life buoyancy degradation conditions already applied. Now, the frequency screening results indicates that the 13 to 14 second period were consistently critical for all the outputs considered, and the values for curvature and bending moments at the 22-second wave period were also elevated for these. Given that these wave periods were already covered in the wave spectrum of the metocean data already analyzed, no further detailed investigations were required. Within the 3-hour storm considered for the irregular wave profile, in the blue areas, the maximum occurring wave was identified and analysis was performed for this maximum wave. A lower response was obtained and no resonance was observed for this analysis. As per ISO stipulations, the results of the loss of buoyancy analysis showed that the umbilical will continue to operate within the acceptable load region should any loss of buoyancy be suffered. In performing fatigue analysis for this study, estimation of the umbilical's fatigue life relied on scatter diagrams, which presents the joint probability of 1-year operational wave height, wave period combinations. Scatter points in this study were binned by sorting and grouping specific wave combinations together in 21 bins as shown in the colored boxes here. For each bin, the probability of each operational wave was determined. The individual probabilities were ultimately summed up, based on which the number of cycles per year were computed. This was further broken down to the total number of cycles for all wave directions considered, generating 168 load cases in total. The fatigue life for 2 critical metallic components, that is the cable Ammar wire and the copper conductor within the umbilical, were determined. The respective SN curves for copper and steel were used in this case. Ultimately, the fatigue analysis results are presented on a logarithmic scale based on a criteria where fatigue damage of 1 is equivalent to failure and 0.1 is the set maximum limit. The umbilical's cable Ammar wire is likely to experience 8 times 10 exponent minus 4 fatigue damage, while the copper conductor will experience fatigue damage of 5 times 10 exponent minus 4. Compared to a fatigue life criterion of 250 years, at the bare minimum, the umbilical will have a fatigue life of 1,250 years. In terms of outcomes, the different analysis undertaken validated the umbilical design in a lazy wave configuration for extreme sea conditions during start of life and end of life operations. The strength of the umbilical is sufficient and the design life of the umbilical is guaranteed with a good safety margin in line with the ISO requirements. Basically, the analysis presented in this study is robust under the set conditions. The umbilical in its lazy wave configuration will operate within the safe load region in the prevailing metocean and extreme conditions with an acceptable fatigue life meeting the design criteria standards. This analysis makes a deterministic conclusion for a stochastic problem in the offshore environment. This is a general method that can be applied to any offshore installation sequence. Research scopes which apply these techniques used in other offshore installations, such as offshore wind platforms, may be explored. Also, modern advanced methods will augment the study outcomes by adding elements such as coupled analysis, digital twin modeling, and complex systems design optimization using genetic algorithms. Thank you.
Perfect, Amma. Many thanks for a great presentation. Over to the judges. Any questions?
Yeah, maybe I've got one, Amma. Thanks. I really, I think first of all, just commend you. I thought came across a very good grasp of the technical aspects that you were talking to. So again, that's really important to be very, very up to speed with those technical challenges. So great presentation. I suppose one of the things I was thinking about, a lot of what you talked about today was about the modelling and the operational phase. I'm just thinking, did you think about or have you explored some of the challenges around umbilical cable installation, that the laying of those cables rather than just the operational phase?
I believe the analysis that's considered in this study is one of the key steps in what you speak about in terms of the laying process. So we typically examine the loads that will be encountered during the installation as part of these extreme conditions, and the loads that have been examined under the worst case weather conditions are more than sufficient to cover the loads that will be seen during the installation process. And mind you, the umbilical is going to be in its operating environment for, in this case, we use 25 years. And within that brief period of 30 minutes, 1 hour installation, the loads that we have calculated for and accounted for in the analysis are more than sufficient to cover such loads.
Okay, thank you for that, Amma. That's great.
Hi, Amma.
Hello.
Building on that, obviously a lot of these umbilicals and that will end up potentially going into late life and beyond the 25-year design sort of life. Any consideration on the modelling for those type of scenarios at this stage?
So this is where we speak about, at the latter part of my presentation, I spoke about a topic called digital twin modeling. So a concept of that nature can be used as a practical avenue where we can predict the life of the umbilical, examine its operation over the period of 25 years and beyond that, and then use reasonable data that is available to us to anticipate the kind of loads or the life of the umbilical during that period, and then how we can transition from that point.
Great, thank you.
Hi, Amma. Paul.
Hello.
Hiya. Right at the end of the presentation, you mentioned umbilicals and floating wind.
Yes.
With regards to that, does the model take into account, or have you considered the power requirement differences between a standard subsea umbilical and when we start moving power from floating wind through an umbilical, as to how that may affect the radius of the cables and how the stress and analysis will go with the higher voltages?
Absolutely. I believe the scope of this analysis here indeed is limited to oil and gas applications, but then further research can be done, and it's actually one of the things that we are considering to extend this to offshore wind applications. And it's a good trajectory going from what we know now to the requirements of offshore wind applications. And they are not too far off, but in this study, this hasn't been covered, but it will be covered in subsequent studies.
Thank you.
Okay, any further questions? Or are we? No. Okay, thank you very much, Amma. Great presentation. And last but not least, this evening we have Sia up next. Sia, are you with us? Yeah, perfect.
Right. Good evening, everyone. My name is Sia. Recently, I just completed a Master Science in Asset Integrity Management. Today, I'm going to present my master thesis with the title of a conceptual model to analyze and demonstrate the adequacy of the piping integrity management for safety critical element assurance. Okay, here's my presentation outline. It consists of project background, aim and objectives, methodology, model formulations, model validations, discussions, conclusions, and finally, recommendations. Okay, based on statistics published by HEC UK on offshore hydrocarbon release, from 2015 until 2018, piping leaks due to equipment failure are in the increasing trend. In 2019, however, there was a massive explosion and fire happened in PS refinery in United States, which is caused by a piping failure. Because this incident was so severe that the refinery had to file for a bankruptcy. So now the question is, what's the tools that industry can use to assure themselves or to demonstrate that the piping integrity management is adequate? So here come to my project aims, which is to develop a model where people can use it to analyze, to demonstrate the adequacy of the piping integrity management in their facilities. So in order to achieve my project aim, I have 3 objectives. First, I need to formulate the model. Secondly, I need to validate it. And then thirdly, I need to evaluate the effectiveness of the model in achieving the project aim. My project methodology started with a literature review, where I need to find out what's the key ingredient required to demonstrate the adequacy of the piping integrity management in specific. From there, I formulate my model and I validate my model. I using two ways to validate my model. First, it is based on the literature data from the industry investigation reports, for example, from CSP United States and also HC UK. Then the second way to validate my model is by try implementing this model in actual facilities. From all the data I have collected, I evaluate it and to see how effective this model in demonstrating the adequacy or maybe perhaps inadequacy in the piping integrity management. Here I want to share some of the important findings from my literature review. First, I realized that to demonstrate the adequacy of the integrity management or piping integrity management, 3 key ingredients is required. First, the model should be able to explain how the system works, how the piping integrity management is assured, secure. Then secondly, the model should be able to instantly show that whatever system in place, whatever safeguard in place is performing. And then the third one is that the model should be able to give assurance that all those systems in place, all those performance has been confirmed through audit or verifications activities. The second key findings I realized from my literature review is that typically risk-based integrity management is adopted to manage your piping integrity. And this essentially is a series of process steps where the output from one process step will become the input to following process step. And I noticed there's one very important behavior in this process loop, where any one of these process steps fail, any single one, the entire system might just break off. For example, let's say a facility fail to identify a certain track in the piping, then the track will just remain uncovered until further deteriorated until final failure happens. I describe this type of behaviors is like a weakest link in a chain, where the weakest link fail, the entire chain just break off. Later in my presentations, I will show you how I validated this hypothesis. So here's a model I want to propose, which I name it as chain lock model. Here's the analogy of my model, where a piping is secure with a chain and various lock. As long as this chain and this lock are still intact, still insecure, meaning that the piping integrity is assured. And this is the conceptual models of where it consists of the containment itself, where people can immediately visualize it, and also series of process steps required to manage, to assure, to secure the piping integrity, and each process step come with the text where there's an indicator to show the performance of each process step. And lastly, it is secure with a chain, which means for the audit and verification program in place to confirm everything is work accordingly. Here is a view of the working model, example view. First, I identify all the required steps to manage the piping integrity based on all the best practice we have code and standards related to risk-based integrity management. Secondly, I choose a very intuitive traffic light color system to indicate the performance. For example, this specific working model, everything is in green, meaning that it is adequate, everything is performing. Another thing I want to highlight is that I also put the indicator on the containment itself. It serves some sort of like a lagging indicator so that it can demonstrate dual assurance as recommended by HC guideline on performance indicators. Okay, here is one of the model validations based on literature data from the industry investigation reports. Like in this model, at one glance, we immediately identify there are 3 inadequate elements in this specific incidents. Then just imagine if these things has been done earlier, then the facilities can immediately respond to those inadequate elements and preempt the final failure incidents. On this validation itself, I also noticed one very important and very interesting findings, where 56% of the incidents will fail due to one fail log, meaning that only one single element fail, but the entire system just break out and causing the final accidents. So this actually validated my hypothesis that piping integrity management essentially behave like a weakest link in the chain, where any of the weakest element fail, the entire system, the entire management system will just fail, break up. Okay, here's a view of my model when I implemented it in one of the actual facilities. Again, it provides a very intuitive view to the audience where is the inadequate elements for these specific facilities, including the contaminant itself, because there are some reported minor slight LPC on these facilities, so it became red. So the facilities personnel, when they have access to this model, they're able to immediately identify where's the inadequate elements of this model, or where's the adequate elements in the piping integrity management, so that they can respond immediately, they can react immediately, reprioritize their focus to prevent, to improve the weaknesses and to prevent the final failure incidents. Okay, I also would like to discuss the capability and limitations of my models. First, one of the key capability is that it is tutorial based, where people can get the reasoning behind all how the piping integrity management is secure, is in place, how is the performance easily. The audience can just grab the overall picture. Secondly, it integrates well with whatever best practices, code and standards available in the industry. And third, it provides a very intuitive view, even to non-technical audience, where the audience can immediately identify where is the adequate elements, where is the inadequate elements, and what is the reasoning behind that, something like that. They can see immediately, intuitively. About the limitations of my models, first, it only surfaces out the direct factors which are available in the piping integrity management. Secondly, it focuses on the adequacy of the piping integrity management. However, it didn't cover anything on the cost effectiveness in implementing all those requirements. And third, it is specifically designed for safety critical piping. One thing I want to stress here is that this chain lock model neither substitute or replace whatever barrier-based safety model we have in the industry. For example, the common one is switches model, or maybe a bow tie model. Instead, this chain lock model are supplementing or complementing those barrier-based safety model by providing assurance, adequacy of specific barrier, especially those classified as safety critical piping. So actually, it is complementing whatever barrier-based safety model we have in the industry. Last, as a conclusions, I formulated a model, naming as chain lock model. I validated it using the industry data and also the real implementations. And on the evaluations, the model can really surface out what is adequate, what is inadequate immediately, instantly to the stakeholders so that they can respond immediately. So my project aim of developing the models has been achieved, which through this chain lock model. As a recommendations, especially in this digital age, I think digitalization is something we must do. We must research how to digitalize this chain lock model. Secondly, it's about the extension of the model, where in my research projects, I focus on the piping, safety critical piping, but perhaps this model can easily extend to other similar equipments like pressure vessel, tankage, pipeline, and etc. As I mentioned just now, there's a limitation of this model where you only consider the only surface of the direct vector. Maybe perhaps how to further research how to integrate this model with others failure concession model, where can surface out the latent factors seamlessly, so that the management can respond accordingly and effectively. So thank you.
Thanks very much, Sia. Over to the judges for some questions.
Sia, thanks for that. I'll start. I think, you know, just first recognition that, you know, you talk about integrity management, such an important aspect of the business in a mature basin, certainly like the North Sea is from oil and gas perspective. So, you know, for a lot of people, it's very, very relevant day to day. So great to see some additional work. So I think you talked about it there just in the next steps. You talked about digitalization. So I was trying to think, you know, what do you feel would be the ultimate kind of output or deliverable of the model? Do you see it being that kind of digitalized scorecard or dashboard, just as you showed in one of the slides around the barrier model? Is that something that, you know, operators or asset managers or integrity engineers would have access to? What's your kind of vision for, you know, where the model ultimately goes as a kind of a deliverable?
Okay, thank you for the questions. I think it is a very good questions. Before I talk about the ultimate visions of this model, maybe the immediate something I can do is that nowadays it is very famous. People using this tool as a Power BI to digitalize all these things, and this is something actually I'm currently working with, so that especially we have a lot of data scattered around the company, and using this Power BI we can just integrate it, and when come to every month or maybe every few weeks, people just refresh a Power BI model, and immediately can see the adequacy of their piping integrity management. Of course, when it comes to the ultimate ends, yes, in this I'm thinking that this should be integrated well in terms of safety critical elements assurance, where it serves like a dashboard to display for the specific barrier they have identified in their multi or switches model. How effective is that barrier? And this is the first thing. It is immediately the owner of the facility can see the effectiveness of the piping integrity management. Secondly, I'm also looking towards that this model can help the auditor, independent auditor, when it comes to the facilities. They can use this model to facilitate their audit activities, then zoom down those things where they claim effective or which they claim ineffective. Actually, this model not only serves as a dashboard, can also use as a tools to facilitate the audit activities.
Okay, yeah. Thanks for that, Sia.
Thank you.
Thanks, Sia. So again, just sort of building on some of that conversation, talking about the sort of the chain lock model, one of the biggest pieces in all of these type of scenarios is human factors and people. And does any part of your model consider that people are sometimes the biggest risk rather than the actual process itself?
Oh, well, yes. Actually, when I developed this model, initially I did try to consider those human factors. However, it might just overcomplicated the model, and I consistently apply this. When I developed this model, I consistently compare against switches model available in the industry, when specifically in safety critical element management. So I realized that even some of the publications, they're very stressful on the so-called hard barrier. hard barrier is something that is something in place, is not really dependent on the human's factor. However, indeed human factor can affect it, but this is the function of this model is before when the human factor start affecting the specific barrier, and before this barrier come into realize into the final failure. So during this intermediate stage, at the barrier stage, it already bring us to face up something goes wrong, something not performing. So from there, people can dig into why this thing doesn't go, why this thing goes wrong, and perhaps they can find out the failure in the human model. Where this is actually one of my recommendations is to integrate this model with whatever safety causation model we have, where we can surface out the human factor, for example, or other latent factors. Yeah, thank you.
Thank you.
Yeah, one final question for me. Very good presentation, and I guess the safety of personnel and assets is something clients focus on more and more, and rightly so. As an industry, we must. How do you think this model can be used to sort of predict failure? Looks like a lot of the inputs to the model resulted in a major accident hazard or an event. Have you looked at any data that didn't, and whether this model would have identified failures prior?
Okay. Actually, okay. There are in my project scopes initially. Actually, I specifically emphasized that. Of course, I didn't present it here just now, but in my project scope, I specifically emphasize that I'm not going to develop a new management system, new analysis method, or new way of how to do the piping inspection, something like that. Instead, I try to integrate all the existing best practices core and standards together, and to have a model to demonstrate how well the facilities manage all those requirements, best practices, management system in their facilities. So that is the goal of this model. So this model serves as a barrier to some sort like to trigger the facilities certain area they are not doing well, so that they can zoom their focus, reprioritize their focus in that specific inadequate area, and respond accordingly. Maybe their procedure is inadequate, or they didn't do the job timely. The facility can respond accordingly to improve the weaknesses, so that to preempt the final failure happens. Yeah.
Understood. Thank you.
Thanks.
Okay, a big thank you to all the students for presenting tonight. A huge amount of work has gone into the dissertations and to putting the presentations together. So it's going to be a tough job for the judges to deliberate. So we will go off and deliberate, and in the meantime, we'll give you a short presentation from Project Director at Global E&C, Derek Thompson, on the speed of change. And we'll be back with you afterwards. Thank you very much.
Wow, before I introduce myself, what fantastic presentations, and no pressure having to follow the incredibly high standards from tonight's presenters. It really is an honour to be part of this great event, especially hearing firsthand the topics covered in such depth and knowledge by each presenter on their chosen subjects. I'm Derek Thompson, Director of Projects at Global E&C, and I'm delighted to have the opportunity to share some of my thoughts with a specific focus on the speed of change we have seen across our industry, and how that pace of change might increase as we stride towards the transition to a different mix of energy, embrace ambitious net zero targets, and adopt the new digital tools that are now at our disposal. But first, I'd like you to picture the scene. Back in 1996, on my first day as a trainee instrument designer, there I was, completely clueless as to what an instrument designer did, or to that matter, what happened in an engineering design house. I just left the Royal Air Force after 6 years of service. So on day one, there I was, typical military parade style with shiny shoes and the razor sharp creases. I was quickly introduced to my boss, and he quickly gave me the full induction, which essentially was an office orientation, which was cut short when I declared I was a non-smoker, and that was me shown quickly to my drawing board and handed my precision tool, a pencil. I have to admit, I actually received more than one pencil, as I went from the accuracy of 0.3 mil all the way up to 0.9. And I have to further admit that for the early days, probably my most used part of that precision tool was the other end of the pencil, as I navigated my way through the alphabet and numbers, trying to keep the same size in a straight line with a bit of artistic license. And it must have been well over 4 weeks before I was let loose on a closeout pack. So that other end of the pencil, where they'd conveniently added a rubber, that was my best friend for those 4 weeks. When I reflect back to that nervous 24-year-old, I'd probably say that the speed of change back in the 90s wasn't quite at breakneck speed, but it was definitely transformational. As quickly, my role from drawing board moved to computer, and we started to embrace, at that point, 2D computer-aided packages, which today is still the mainstay for a lot of designers, albeit they may have moved into the three-dimensional sphere. However, it's my view in the past 5 to 10 years, the speed of change has taken on a different pace and is getting quicker as we embrace the digital revolution. Just take a look at your smartphone and how critical it is to just about every aspect of your everyday life. Global E&C recognized several years ago the need to embrace and be ready for this change, and more importantly, the speed of change, which led to significant investment in the development of our in-house digital ecosystem, Slingshot, which has been created to offer a robust and integrated business platform across our whole business. This precision tool for us is essentially our smartphone for today and our smartphone for tomorrow. I hope some of you can remember and know about Slingshot and the fact that it was a precision tool used by David. Remember that little shepherd boy as he took on and successfully beat the big, massive giant of Goliath. And it supports, in some respects, our reality and focus on pushing the boundaries for global E&C in an environment that has historically been occupied predominantly by the global tier 1 organizations. With global, our speed of change continues and is supported by our 3 pillars of mindset, agility, and digitalization. Mindset. Let's start with the first thing that was shared with me during a chance conversation I had back in March with Terry Allen, Global E&C CEO, as I weighed up a number of options from a work perspective. Global E&C will be the most digitally led EPC contractor in our market sector. That was Terry's first words to me. Wow, we're talking a bold statement, was my first thought, but something I definitely wanted to hear more about. After several more meetings and discussion, and things became clearer in terms of what that actually meant and the commitments, my decision was made that I wanted to be part of an organization with such a clear mindset. Bear in mind, this decision was made back in 2019 and was quickly faced with the unprecedented market and commodity crashes that you can clearly see in the graph here. I think we can all look back to that period when it was March 2020. Those events drove many organizations to cut discretionary spend and would have really tested any mindset. As the only way, and within Global E&C, that did test our mindset, but we recognized that it was the only way this goal was going to be achieved was that we continued through a significant investment to develop that digital ecosystem to support our business. Of course, mindset also sets the tone around how open our people and teams are to embracing change and continually driving for improvement. It's also how we embrace people's diversity of experience, thinking, and who they are. One area that is of interest to myself and support across our business is the support towards superpowers of around 20% of our population that are neurodivergent and really do bring different perspective. There are many aspects to consider, from recruitment to work environment to task-specific activities, to help us tap into these talented individuals. And it's great through our partnership with Grampian Autistic Society, we're committed to making changes to ensure our business attracts, retains a workforce across both the neurodiverse and neurotypical spectrum. Agility, from my perspective, has been able to see opportunities for change and to ensure the organizational design of our people are equipped to adapt, change, and react quickly to the environment in which they operate. Agility isn't an easy skill to teach or to implement, but there are some areas that I believe you should put your focus. Have a look at this busy slide. It's clear you can see so many interactions that were part of the brownfield service and business line. It shows where there's multiple manual process, disparate spreadsheets, emails, and a whole load of interactions. This at best is a series of speed bumps, and at worst, those frustrating moments where you're sat at a set of traffic lights, looking at a red light and seeing no reason to be sat there stationary. I'm sure we can all relate to that drag and the delays from such instances in our organizations. But haven't thought it possible or practical to imagine a world where these systems support an agile delivery model. Our digital ecosystem Slingshot, and in my role, means I now have direct and critical interactions with our in-house team of analysts and developers. Agility comes by having this team as part of the overall delivery capability, something that is today a reality as the team size for our Slingshot team matches the same team size we have for our project controls, which is fantastic, but definitely a new experience with roles that are more akin to software companies than an EPC contractor. This isn't an exhaustive list, but it's certainly key areas that were a significant factor when looking at organizational design to ensure it supports ownership at the right level for complex processes and interactions. So you can map them out and ensure agility is intrinsic to our ways of working. Digitalization. If I take you back to my precision tool, things have changed. And in the context of today, will continue to change when you consider the evolution of Web 3.0. Web 3.0 has many characteristics, but one characteristic that's really of interest to me, and at its core, is ubiquity or interoperability, which is best illustrated by distributed ledger technologies such as blockchain. With this evolution, it means the focus around supporting our people needs to be now fully immersive experience in our Slingshot system, with a view to work towards essentially digital literacy. So creation of a passport or a license, if you want to call it that. This approach will help ensure that individuals by position or role are supported towards being competent to work efficiently and effectively. Essentially a similar process to what we do with our field trades, with practical theory and evidence-based activities used for our guys and girls who use chain blocks for our lifting operations, but in a different setting, pivot towards blockchain technology as we embrace the use of this technology in our business. We're currently considering how we, in a focused way, adopt blockchain to manage our Scope 1 and Scope 2 targets within our net zero space. And we also recognize that quickly that focus needs to turn towards more challenging Scope 3 responsibility, which covers our people and our wider supply chain. Further opportunities to deliver change will quickly come into focus across many other aspects of our service provision, especially when you consider its potential application in the areas of engineering solutions, contracts and procurement, and that's not even straying towards what can further be unlocked by machine learning and artificial intelligence. We're now at the point where the judges should have finished their deliberations and come to what I can only imagine is a very difficult decision. So in summary, unlocking potential to realise the benefits as we embrace a world that will face change at speed we've never seen, from my perspective, will only be achieved by having a clear mindset that nurtures individuals and teams to seek opportunities to improve process and benefit from information. That will become more ordered and credible so organisations can remove speed bumps or delays and offer more agile outcomes. Software can and will be a catalyst to breaking down these barriers by looking to develop small, reusable, and resilient microservice software packages that offer improved interoperability and solutions that can easily be adapted and adopted. Supported by Slingshot, my focus is towards new software technology to eliminate needless delays and develop smart solutions. So agility is at the core from the project service line and help us change at pace to the ever-changing markets and reoperate within. In other words, be a digitally led EPC contractor. Thank you for listening.
Thank you for this interesting presentation.
Welcome back, everyone, and I have the results. No gold envelopes. Katrina, what's, the word stylers might have not just a bit of paper. Take note for next time. So we had an interesting discussion. I would like to say thank you once again to all our presenters. I know it's not easy, especially over Zoom, to present on some of the technical details and also trying to condense it into a 10-minute presentation. So well done to everybody. Very fascinating insights to your dissertations going forward. So as always, and as tradition, we will announce the winners in reverse order. So I will go with third place, and the prize of £100 goes to Larissa on her presentation on the solar water pumping system. So well done, Larissa, for being our third prize winner. I'm then also now going to say our second prize winner, who will receive £150 prize money, and that is to Amma on her umbilical cable study. So well done to Amma on that one. And the winner. Everybody's waiting. Everybody's holding off. The £250 goes to Anna on her flow control for CO2 well. So well done, all three ladies. Deserved winners, and also to the other two, well done for your presentations as well. So it was a very difficult decision by us, and it was a tough job. So thank you for your efforts. I'm now going to hand over to Paul, who will give us our closing remarks and bring us to a close. So over to you, Paul.
Thank you very much. So just before we close, I'd like to say I'm delighted to have served on the judging panel tonight. I'd like to thank the other judges for their time and support this evening, the Energy Institute and Global E&C for organising the event, the universities and staff for supporting the students to achieve such a high level in their respective fields. But most of all, this evening is about the efforts of the students. These hard-working, articulate students are a credit to themselves, their universities, and an inspiration to all of us. It's through the passion and curiosity in solving problems, along with the sort of research and developments that you've shown us this evening, we're clearly able to see the skill, high expectation, and commitment of both the students and the university staff. All of these presentations we've seen are great examples of their respective disciplines, and I'm certain every one of you has an exciting and inspiring adventure in front of you. I look forward to hearing of your positive impacts in your specific fields in the coming years. So lastly, some thanks for making this evening happen. Our talented students for taking part, thank you for your time in preparing your presentations and sharing your projects with us. The judging panel for your experience and posing some very tough questions. Our university contacts in the help in selecting their top students, Roma, Mohammed, Debbie, Professor Kemp, and Professor Steele. Adam from Live Evolution for the videography and streaming. The Energy Institute for sponsoring the event and the prize fund. Katrina Dunbar for hosting and organising. And at Global E&C, thanks for sponsoring this event and providing this challenge centre. The support of Catherine Milne and Diane Morris and the rest of the team for making this event a success. And to all our attendees joining us, I'd like to thank you for your support. And with that, we'll close.
And we would
Oh,
like to
sorry.
see if Larissa would like to, not Larissa, sorry, Anna would like to say anything on her presentation and her winning entry.
Well, what an honor! I just want to say I'm really happy given yeah, the high caliber of presentations, and just to be shortlisted is a great honor. So congratulations to all of us, really, and thank you everyone for your time tonight. I know it's difficult to everybody's online these days, so thanks for everyone coming, for the panelists, and to RGU, especially Mohammed, who's been a big help, and my company and the operators who give me the data, and of course my family and friends, Jason's on just now, who have put up with me talking about this for the past year or so. So so thank you very much.
Thank you, Anna, and well done. So thank you, everybody, and we'll see you all next year.